Good afternoon. I don't know, before I introduce Roger, I think I had an epiphany. I was tasked with putting together part of Roger's presentation, and part of that was doing a highly abbreviated CV, which you're going to see in a minute. And I was struck by the notion that the people we have speaking for us today, Roger, Wayne, Nelson, they probably started out about like we did. I mean, I don't know about you guys, but I was fascinated with this electronic stuff at a very, very early age. And, but it took me a very long time to figure out what I wanted to do and where I wanted to go with it. And essentially not really settling down into any career stuff until I was a very young adult. And then we have people like Roger over here, that he, like many of us, started doing projects with for parents, uncles, friends, whatever, and he knew immediately that that's what he wanted to do. And people like Roger and Nelson and Wayne, I think parts talked about it. And maybe not so much to the rest of us, but that's why we're here trying to glean some additional insight into all of this. And I don't know about you, I'm really grateful that we have people like these gentlemen here to speak to us today. So, without further ado, Roger.
Thank you. They told me there was a stick. There really is a stick. A real stick. So how many of you have tube equipment? I have to ask questions first. Oh, wow. Yes. Okay, yeah, you can read while I bore you. Okay. And this mic is working, or do I need to be here? Are they getting this, or do I need to be here? Is this where I'm supposed to be? Well, you should tell me that. Thought I was already wired for sound. Is that good? All right, we're good? Too much bass. Too much bass on the mixer. Which I'm the guy who sometimes there's a live thing going on. I did this in Australia. And the guy said, it was just horrible. There was too much bass, way too much bass. I go up to the guy and I said, could you just like turn the bass down a little bit? And Australians are really kind of nice. He says, hey, why don't you just have a go at it? And he just walked away and I had to go at it. I've done that a couple of times. But some sound people get really upset. And the bass is too loud and they turn it down like 2 dB. And that's only 2 dB, man. And then turn it down. How many people here are curious about tubes but don't have them? God, you all have them, okay. How many people came to hear me talk stories about dead tube designers? Yeah, okay. I might, I do that sometimes. All right, so let's get into it. So this is what I did when I was a kid. No, if you all read it. I know what I did, I don't need to read it. I can't see that very well. I wonder, what if I do?
Here's the cliff notes.
All right, what if I do this? Go ahead.
Well, the cliff notes are that Roger designed his first 3-tube audio amplifier at age 11.
Or so, yeah, I found it the other day. I still have it. I found it the other day.
Yeah.
It's a little tiny thing. It's like, how did I put all that stuff in this little tiny box?
And the rest of us are still struggling to keep up and not doing so.
I will say, when I did the first one when I was 11, it kind of came out of the RCA book, okay? But there's a lot of stuff that came out of the RCA book. So if you want to look at some good designs, get yourself a couple of the RCA manuals. How many people have an RCA manual? Oh, you guys are in good shape, okay. Get a couple more, because if you get the really old ones, they're very cool. Get a RC10, by the way, which is the very first one. They started with 10 for some reason. RC10 is online. It's a PDF. It's not a great PDF, but it's there. And RC10s are very expensive. Like if you wanted to buy an RC10, it's a lot of money. But actually, if you're into tubes, I'll recommend this. If you can get, and there are people who sell these on eBay, the oldest RCA manual you can get, if you're interested in what the really early tubes were like, that's the thing to get. I have an RC13, I think is the oldest one I own. And they're like $200 these days or something like that. Okay, so we're going to talk about tubes. And the first one is preamp tubes. So let's advance and see what we got. Now, does anybody know, this is a single triode. Do you know that same tube appears in a double triode, in a 9-pin base? Does anybody know what that is a double triode? Thank you. So if you wanted to make a preamp, and you could get a bunch of 6A V6s, and they happen to be quiet, you never know till you get them, you can make yourself a 12AX7 preamp with a bunch of 6AV6s, which might start to be a good thing because 12AX7s have gotten really expensive if you want like new old stock or something like that. So I bring that up because it's interesting when you look at the 12AX7 in the RCA2 book, they immediately refer you to the 6AV6. So let's see what we have next. And there's a 6AV6. Now, this is a General Electric. Every company, most of you looked at out of the book data sheets like the GEs and the stuff, and you can find all these online. You can either go to Duncan Amps, and you can put in a tube number, but you can also nowadays, Google has gotten it down so much with the tubes, that you can just put in your type, you put in 6AV6 data sheet, and it takes you often to Frank Pocknet. F-R-A-N, you know Frank? Well, Frank is the guy. I don't know where he is, I think he's in Europe or something, but he's got the, do you know about Frank? Is he in Europe?
I know where he is.
Yeah, he's got the most listings of tubes. So if when you go to Duncan Amps and you put in a tube, and you go to Frank's, there are a whole bunch of different people listed, but Frank will have 20 different data sheets of 6AV6s. But the thing I don't like that Frank did, and nobody's doing it, they tell you how big the file size is, but they don't tell you whose data sheet it is. Because I'm very particular on some tubes you really want to see maybe a Telefunken, or you want to see a GE, or you want to see an RCA. And then RCA had these ones like, well, we'll show you one later, that were in their loose binder, and those are different than the ones that are in the manual. The manuals we buy, the RC manuals, are pretty much sort of between the public and the hi-fi guys. That they were made more for the general public than, say, for the engineers. A guy who's an engineer would probably have the individual binders and stuff, and he didn't have the internet, so he had to have all the. I'm going to give or sell somebody my Tungsol collection is this big. I Xeroxed the whole Tungsol book. It's in 5 binders, and now I go like, why am I carrying that around? I can just go online and do this. So here we are with the 6AV6. It's half of a 12AX7, and it has those 2 little diode plates that I don't know what you want to do with them. You might do something with them. You might do a clamp, Bob Carver clamp, which I still don't quite know what Bob's up to with that. He thinks the tubes will last forever if you do that. So let's go to the next slide and see what we have. Now this resistance coupled amplifier thing, we'll see more of this later, but this is in the back of the RCA book, and this is why it's so easy to design with the preamps. And most of this talk is going to be about the power amps, because they're a lot more interesting. The preamps, you just kind of choose a plate voltage, and you'll see it a little better next time. But they show you where all the different parts go, and there's a couple pages of explanation that precede this. So this is in the back of every RCA manual, and if you go look, you'll find it. So next, let's see what we have. So here we have curves. These are our standard triode curves we've seen before. You've all seen these. This is kind of interesting how this one kind of goes backwards a little bit, which means you don't want to play around in that region too much. And most of us play around in the, 150, 200 volts, kind of, and pretty much less than a milliamp. But these curves are interesting, but people try to say, well, what makes a triode really have low distortion and so forth? And they say, well, it's the spacing of these curves. But that's kind of hard to determine, like where, and you can draw a load line on here and do all that stuff. Let's have the next slide, though, which I hope has something more interesting. It may be at the end when we get to the 12AX7. Go ahead, it's all a mystery to me. What is this one? This might be one of the ones I didn't care about. Let's go past that. I think that was for the diode. Now, 6SN7s. How many people like 6SN7s? How many people know what current they run at in your amplifier? How many milliamps?
So I think the book is 8 milliamps, 250 volts.
8's pretty good. I think a lot of people, Herb, how low do you see people running them? You know something about this.
I don't know.
A couple milliamps?
But you try to run them as hard as you can.
Oh, hard as you can. All right. He's from New York. So that's Herb Reichert if you all haven't met. Herb's fun to talk to. 6SN7. Okay, so here's our Tungsol data sheet. Now be aware, do you know who owns Tungsol these days? That's Mike Matthews. Mike Matthews is the king of the tubes, and he can really get us if he wants to, because he's the only guy making a lot of this stuff. Of course, we have JJ, and we have the Chinese, and the Chinese are actually doing some things very well now, much better than they were in the beginning. The Chinese made a really big mistake. I just want to say this quickly, because I use Chinese tubes, and they're quite good. It's that the bad ones are quite bad. And the problem is in China, as I understand it, you have quotas. And the more tubes you put in the box at the end of the day, the better the day. And as far as they're concerned, if you hold it up and it looks like a tube, it really doesn't matter if it lights up or not, it goes in the box. So what they were doing was shipping about 10 to 20% of tubes that were just non-functional. It was bad soldering on the base, it was sometimes an internal connection that was open. But generally the tubes that passed, the tubes that worked quite well. And a lot of people don't know that. So I want you to know the Chinese tubes were good then, and they're better now. And they're a good alternative. So here's your 6SN7, and it's your standard data sheet. You guys seem to know about this, so we can move on to show you the curve I want to show you. So I thought this curve was, go ahead. This curve you will not find in many places. This is the curve of mu versus current. Is it very clear? I'm up close. Can you all? Okay. Well, what I'll tell you is here is 10 milliamps, I believe. And there it's kind of, so this is mu, and see how mu's falling off at lower currents? What we're looking at, what makes a tube, what makes a preamp tube have low distortion, which is another word for linearity? You know, people love to use this word linear, like, oh, linear, yeah. What do you mean linear? Well, linear means that the voltage amplification is always the same at every part of the swing of the signal. So when you swing a signal through a tube, you're going back and forth on this plate current, okay? Well, if you're in this region, it's telling you the mu is constant, so the gain will be constant, so then the distortion will be low. If you go into this area where it's dropping off, anywhere in this area, you're on a slope, and the gain is not constant. So the thing to take home with you is run them above 10 milliamps. And the other thing to take home with you, if you want the plate current to be fairly constant, you can either use a current source, which some people don't know what a current source is, right? Current source is like a resistor of infinite resistance, but it passes current. A choke will do the same thing. If you got a choke, you can put a choke in there as a plate load, and a lot of people are doing that. It's got to be a good choke, and it's got to have good, it doesn't have to have necessarily good bandwidth. It has to have low capacitance, which is a problem, and it has to have low saturation at the low frequencies. So the hardest part of a choke is, say, getting it to go down to, say, 20 cycles. It just gets to get bigger and bigger as you try to go lower and lower. Or, and this is what I like to do, because I don't like to build current sources, because current sources can also be noisy, and if you short something out, is the current source going to handle it, and all those things. And it's got to be made on a little circuit board, probably. I'm very concerned with, especially with hobbyists, what can you hand wire and what can you not? How do you hand wire an IC, for instance? And the SOT is going to be even more tricky. But you get a little board, you know, and you kind of go for it. I will say this, by the way. I'm an old timer. I like to draw things and do things the traditional way. I don't like CAD very much. But the programs out for circuit boards like Eagle, the simplified, the free version of Eagle that lets you make a board about that big, is pretty easy, actually. The hardest part is finding the damn parts, because they make you take parts out of a library, and then the library is connected to DigiKey, who wants to charge as much money as they can. How many people know what ND stands for? I have these kind of consciousness things. Okay, who can tell me what ND stands for? Right. Well, if you're a purchaser and you see ND on the end of a part number and you don't know it stands for anything like that, you don't know that's necessary, you have to go and buy it from DigiKey. Because they're the only people who make things -ND. I think everybody should put -ND on everything, and then I'm not fond of DigiKey, by the way. Mouse is nice. So the other way to do this, which I like to do, is use a very high voltage power supply and a very high resistance resistor. So let's say that you're willing to put 450 in the power supply, for instance. That's pretty high for a preamp, but why not? And then run the plate, you know, down in this region that's 100 volts or something like that. And the other thing is you'll get higher gain out of the tube and you'll get more linearity. Remember, by the way, that mu curve is drawn at a constant current. So if you want that effect, you need to give it a fairly constant current. So that means don't use 200 volt plate supply and a 10K resistor. Okay, use like a 450 volt supply and maybe a 45K. You can use a 45K, and you'd be up there, 40, 45, or 7. Let's go to the next one. I want to get to the power tubes because they're more fun. Okay, we're doing the 12AX7 that you all know so much about. You all know that it was kind of designed to be the replacement for the 6SL7. So if you're into octal tubes, how many of y'all know about the 6SL7? Not as many, okay. The 6SL7 was really meant to be a preamp tube. I encourage you when you open your RCA manual, read the first paragraph. They'll tell you exactly what they were thinking when they designed that tube. And although audio comes kind of at the end of the list for the 6SN7, it's the first of the list for this tube. Because this was really designed to be an audio preamp tube. And it's sort of the 12EX7 of its day. I think the 5751 is, no, it's the 6, I think it's the 6072. Someone told me who worked for a tube factory that it was their job to make the tube that would be the 9-pin version. Because what you can do is, even though you're shrinking the tube, you can still have those same characteristics. And what are the characteristics we care about? We care about transconductance, plate resistance. Is it possible to back up a slide real quick? I bet it is. These two curves are interesting in that this one's the transconductance going up. I'm going to talk loud because I'm not by the mic. This is the transconductance going up with current. And this is the plate resistance falling with current. And the multiplication of those two is this. You all know that RP times GM is mu. All right, mu has no units. And it's just gain. So it's showing you that after 10 milliamps, these two things are interacting in such a way that they have a constant product. You can see they're still changing, but they have a constant product now. So here's the problem with a low plate resistor. With a low plate resistor, you go sticking something in parallel with RP. And now these two things aren't going to cancel because now RP is not purely RP of the tube. It's now RP in parallel with your load. So don't load your tubes, okay? There's an amplifier out there, they're loading a 12AT7 and putting the plate in the feedback, and I'm going, what the hell are you doing? He said, well, you have to build it and listen to it. I said, I don't think I want to listen to it. Let's go ahead and do the next. So let's go back and we're forward to, I think we're at power amps now, right? If we go forward, we did the 12AX7. Oh yeah, I want to go through, we're just going to go through this real quick because it shows you how complete some data sheets are. So let's go page 1. Unfortunately, it's in German, but maybe you can't read that far away. But there it is. So this is Valvo, lovely company. Next slide. So they're giving you the characteristics, and they're showing you kind of maybe some tests there. Let's go to the next one. Sometimes you can find these in English. They're showing you a bunch of applications here. Let's go to the next one. Oh, there's some curve. These are unusual curves. Let's go to the next one. Not used to. There's your curves you often see. This line, by the way, if you don't know, that's a dissipation limit. So these, you have to stay on the inside of that so you don't over dissipate the tube. Next one. By the way, if you over dissipate something, most preamp tubes, if you run the dissipation too high, they're going to get really distorted anyway. And if it's a 60J8, I encourage you to use it at about, it's rated for 2 watts per side, and I'd use it at like a half a watt. Because if you go to the 2 watts, they short out. The grid's so close to the cathode that things happen. So if you want reliable, and with a tube like that, you don't have to run it that hard. Let's go to the next one. Okay, so let's do power tubes. This is what I really came to talk about. How many minutes am I into this? 30. Ooh, I wanted time for, all right, let's go. So 6550, there's what it looks like. Let's go to the next one. Typical applications. Let's go to the maximum ratings. By the way, you do not run a tube at its maximum dissipation. Maximum dissipation means you'll be lucky to get 1,000 hours out of it. If you run it at half dissipation, you might get 10,000 hours out of it. That's why I run all my tubes at about half dissipation. That's how I get the life in the RM9s. Okay, so let's go to the next one. So don't run them at maximum. So here's some typical push-pull amplifiers. You know, cathode bias is always going to have less power. Cathode bias is always going to give you trouble when you put it on a scope and it's the, you know, the grid voltage goes up. And cathode bias is great for music, but it won't look good on the bench. I'll just leave it at that. I don't think I'm going to send John Atkinson a cathode bias amplifier because he wants it to look good on the bench. And then here's the pentode connections. And here's all, they threw ultralinear in. You know, David Haffer thinks, and he's a lovely man, or was, but I think it was done in England much earlier. And ultralinear is kind of cool, but it's not the world. All right, there's other things besides ultralinear. One thing about ultralinear I want to say real quickly is that you know, you have feedback from the screen taps, right? And everyone assumes that those screen taps are doing what the plate's doing. Well, put it on a scope sometime at high frequencies, you'll find that the screens and the plates are not doing the same thing. It's very hard to wind an ultralinear transformer and get that tap in there and get the tap to do what it's supposed to do. So I've done it, but I don't do it all the time. So let's go to the next one. Plate curves. Look at the little wrinkles in some of the plate curves. Look at these little wrinkles. These are the wrinkles that are not supposed to be there. Does everyone know what KT stood for? Kinkless tetrode. Well, those are the kinks, so there's still a few left. Because this is, in all honesty, a KT88, and I don't know how good the KT88 curves were. And you don't know how honest the curves were, because if they wanted to, they could have kind of flattened that out a little bit. I'll tell you this, if you take take a bunch of 6L6s, it's more common with 6L6s than anything, and put them on a curve tracer, you'll see more difference in 6L6s than any other tube I've ever seen. And it is in this region, where they didn't quite get the kinks worked out at the low levels. And what's even more interesting is that you can take a company like Sylvania, who's made that tube from the beginning, and different sort of ages of Sylvanias, some are a lot better than others as far as these curves go. Some are kind of bad looking, and some are really nice. So here they are. These are the plate curves. By the way, as a point of advertising, I'm soon to offer a curve tracer, I hope somewhere around $1,000, that you can USB into your computer and draw curves on physical paper and overlay things and all this kind of stuff. It'll be a box, and you plug your tube in there, and you hook it up to your laptop, and you'll run some stuff, and it's going to be really cool. And it'll do lots of current and lots of voltage, and it'll be a good one to have. So let's go to the next one. I love curve tracing. This is what happens in ultralinear. You can see that ultralinear somewhere between, pentode curves always go, why, if a pentode curve is like this, if it's horizontal, what does that mean about the plate resistance?
It's very high.
It's very high. And if it was perfectly flat, it would be infinite. Now, some people think, and I'll get up to the microphone for this, some people think we match an output transformer to the plate impedance of a tube. How many people think that? Don't be shy. You all aren't that smart, come on. All right, well, then you are, so you don't need the education. But you don't do that. This plate impedance, so many people think, you look up the plate impedance, well, what if the plate impedance was infinite? Because a perfect pentode has a flat curve at the top, which would be infinite plate impedance. What really happens when you decide what the load impedance is for an amplifier, it's all about the voltage and the current, and nothing else. You choose a voltage, you choose a current, you look at some curves and decide how much current you, let's go to the next one to see what we get. So these are just distortion characteristics. They're showing you how the power goes and how the distortion goes for one of their applications. You don't get this terribly often, but you're going to see a lot of it in the next couple slides from Philips. So let's go on. This is another amplifier, I guess. That's more curves. Let's go on some more. Oh, God knows what that is. Okay, let's go on some more. Here we go. I really like this one. So let's go do this guy. Okay, the Philips. As far as I know, did Philips create the EL34?
I believe they did, yes.
I think they did too. So they show you a picture of it. Let's go to the next one. And they give you a lot of applications. Look, these are the characteristics. And luckily, this is in multiple languages, so you do have the English for it. And they talk about these different things and how much power you can get, and this is probably the class A1 or maybe some small powers here. Most people think a pair of EL34s is good for, 35, 40 watts, because it's a Stereo 70, right? Or it's a Marantz Model 8, or it's a how many ICO amplifiers, 35 watts per channel keeps coming up, ultralinear, 35 watts. Like that's been done enough. We don't need to do that anymore. So let's go to the next one. And that's the one. Look at that one. 100 watts out of one pair of tubes. How many people believe that's possible? Hey, it's on the sheet. Well, I've done it, and it's possible. It's not the greatest thing. I didn't like all the sound of it particularly, but it is doable, and it shows you that Philips was thinking about a lot of things when they invented this tube. In that they said, hey, you can go all the way up to 100 watts. And I did this mainly because my friend Bruce De Palma had already done it. And told me about it one day, and I said, oh, come on, Bruce, you got to be kidding. He says, it's in the data sheet, and he had the originals right there. He said, here's the data sheets, it's right there. I said, okay, and it's true. These people didn't lie, they knew what they were doing. By the way, do you know that the EL34 is a much less expensive tube to make than any of the other power tubes? Do people know why that is? It's because it's a true pentode, it's not a beam tube. And in beam tubes, the grid 1 and grid 2 wires have to align with each other and shade each other, and that's very hard to do. requires a lot of tweaking of the grid winder and the grid insertion, all a lot of mechanical hand stuff. Whereas with a true pentode, you just wind the control grid, you wind the screen grid, you wind the suppressor grid, and the relationships, they have the right number of turns, but they don't have to line up with each other. So that makes the manufacture of the tube a lot cheaper. I hate to say I could buy these tubes for $2 a piece back when I started. So, from RFT in East Germany. But I think you have to thank the communist system for making that cheap. Let's go to the next one. There's more applications. Let's go to the next one. Here's some curves we've seen before. Let's go to the next one. These are the ones I wanted to, we can't rotate on the fly. So if you turn your head sideways, the reason Philips did this is because they wanted to give you the curve as big as they could on a sheet that's, you know, about a half of an 8.5 by 11. And they could have, sometimes they turn them this way, so you get two, but then they're not as well defined. So you have to, you turn the book. All right, so let's go to the next one. I'm sorry we didn't turn these. These are just characteristic curves again. Notice this. Look how rounded that is compared to the, you know, just turn this sideways in your head. The pentode curve would come up like this in a very straight line and then make a sharp corner and then go this way, okay? That's called the knee. That corner is the knee. And see, this knee is hard to define because it's not very sharp. But the knee on a pentode is really easy to see. And we designed for the knee, by the way. That's the thing that determines the plate load resistance, is you kind of shoot right through that knee or below it. You don't want to shoot above it. Let's go to the next one. So here's one of the amplifiers, and they're showing you the power output. I've got a stick. Where'd the stick go? They're showing you the power output on whatever one sort of keeps going up. And then they're showing you how the plate current goes up. And here's a little bit of screen current going up. And there's some, I don't know what that is. Oh, that's the anode current. Let's go to the next one. Let's see. So here's another one. Let's go to the next one. I mainly put these up here because I wanted you to see how much information Philips gives you as compared to some others. Keep going. So they're giving you the performance characteristics for all those different applications that they put in the table. And if you are interested in making an amp from scratch, just grab one of the original applications and start there, and then play around. So let's keep going. So you kind of choose by power. So here's a 70-watt application, and that would be in the previous tables to tell you what to do. These people, basically in the day of tube design, if you knew enough electronics to understand this, you didn't have to do a bunch of calculating. You could kind of call up and say, I need an 8,000 ohm transformer, and I got to make a 400 volt power supply, and let's go. You know, so let's go to the next one, another application, the next one, another application, the next one, another application, keep going. Okay, next, this is the good one. This is what we've been building up to. I'm probably already over time already, am I? Okay, here we go. I want some time for questions. So here's your 6BQ5. It's a tube everyone knows and loves. Yugoslavians used to sell this for $1.25. I got very interested in it. I think I bought 2,000. This shows you what they do. Let's go to the next one. The Yugoslavians made a really good one until the factory was destroyed. Now, these are two suggested applications right out of the RCA book. And here's Roger's application, okay? Because I make an amplifier that does 35 or 40 watts per channel with one pair. Now, does that bother anybody? It bothered a lot of people that I went to a little presentation, and some guy was, I don't know if he's not here, was really bothered by this. He said, well, you're going to over-dissipate the tube. Everyone says you're going to over-dissipate the tube and burn it up. I said, no, I don't burn up tubes. So here's what I did. Instead of using this rather low voltage of 300, I'm using 700 volts. People say, well, you can't put 700 volts. Oh, yes, you can. You can put 700 on the plate if you don't be stupid and put 700 on the grid, on the G2. So you keep the G2 down. And I'm even up at 345, but I determined that was okay. Then, so here we're showing, so there's their voltages and those are my voltages. Then we talk about plate current. Well, their plate current's rather high and my plate current's rather low. Well, I have to keep it low to keep the dissipation down. If I'm going to run twice the voltage, I got to run half the current. We all are running these 6BQ5s pretty much at the max, which I'm not nuts about, but it's a fairly cheap tube and that's how everybody runs them. So I don't expect to get 10,000 hours out of them. So then we have the current at the G. Now a lot of people get concerned about the G2, and they should, because a lot of amps fail because the G2 is either over voltaged or over currented, and what happens, I've watched it inside the tube, one of the screen grid wires will start to glow. and it'll glow orange. Just one wire maybe, because it's getting hit with a bunch of electrons. Well, then the screen wire melts. When it melts, I have a tube that did this. It shoots a beam of electrons through the plate and makes a nice little pinhole, and the tube I have, it shot it through the glass and put a hole in the glass and let the vacuum out. And that's the end of that. So couldn't get the vacuum back in. So if I could, we always talk about letting the vacuum out. You don't let the air in, you let the vacuum out, right? Okay. Now, do you know, I have to add these little asides, they sent up a satellite with a traveling wave tube in it, and it was evacuated to test, and it was sent up evacuated, and it had a cork in it that they could pull out once it got up there, some way to open it to the space, because space had a better vacuum than they could produce on Earth. If you think about a vacuum, how do you get the last molecule out? You know, when you're pulling a vacuum, these are molecules pulling other molecules. Well, how do you get the last molecule out? That's the problem. I guess if you leave it up in space long enough, it just kind of drifts out the hole, all right?
Tip it out.
Tip it, I like that, tip it out. All right, now I go up to about 98 milliamps so I'm going a little higher than them, but not by much. But this is my screen current's nicely low. Why is my screen current low? Something you may not have noticed yet, I noticed a long time ago, that once you've found a particular tube, the screen current is a pretty constant percentage of the plate current. And in beam tubes, they're trying to get that screen current the lowest. So if you want to know if a screen tube had the best wound screen grid, you look for the one with the lowest screen current. And that means that that very few electrons are hitting that screen. But you don't know, they could be kind of focused in one place. You don't know about the concentration, but you know about the total. So the total current's lower because the plate current's lower. And it's not quite linear there, that's an even lower percentage. Then we get to the max current, and this is what the guy was all worried about. These go up to 22 milliamps, I only go up to 3.6. But what's really important is when you multiply some of this stuff out. But one other thing to notice, if you ever looked, the application for this tube is almost always an 8K plate-to-plate load. By the way, that's a bad way to express the load. What's the load on a tube? What's the load on the individual tube in that situation? It's only 2K, it's not 4. And so we express it that way, I think, because it's easier to measure the transform, but the load is seeing 1/4 of that. Okay, not half. So when you draw the load line, you got to make sure you do that. So there's my 40 watts before the transformer. I actually get about 50, but then the screen current kind of goes up. So then we look at this. What's the plate current? What's the plate at idle? And this is for 2 tubes. And all these are for 2 tubes as far as the current. And then you look at the dissipation. Now we're getting into the thing that really determines if this thing's going to blow up or not. So they've got this plate dissipation, and it's rated, I think, at 12 watts per tube or something like that. So we're trying to keep it under 24. So we're all under 24 here. And I'm in between those two guys. But I get to subtract out more power. Here it is, here. This is the thing I want to look at. That's the idle. Okay, so the idle's not too much of a problem. In the idle, you can kind of cool the tubes off, and you get a little more distortion, but not much. You'll find a point. By the way, this thing about biasing, we don't have a formula for bias. We just make it up. It's like it's a trade-off between life and low distortion. There are a lot of people who crank it up, run the tubes hot, and they think it sounds a lot better, and if it does to them, they can just buy more tubes. So you really reduce the life. So here's the plate input. Now, the plate input's real simple. It's just the voltage and the current going into the output stage. So you measure the B+, you measure the cathode current, you multiply them out, and you get these watts. Well, my input's a whole lot larger, but my output that I get to subtract off is also a lot larger, and then that's the resultant dissipation. Theirs is only 8 at full power, and theirs is 10 and mine's 24, but I'm still right at the limit. But that's for full sine wave continuous power, and we don't play amplifiers at full sine wave continuous power because there'll be some distortion, a lot of distortion. You know, you have to play about 20 dB below the peak level to not clip in most music, at least 20, and some people say a whole lot more. So really, when we get down, we're really wanting these amps sort of around idle, but the purpose of the RM10, one purpose was to show people this could be done. I just had a lot of fun with it. But the other thing was to say, look, I've got a ton of reserve power here. You can really, if you need that peak, if you're sitting there running at 5 watts and you have the standard, 15 or so, 12 watts of the kind of, 17 is the standard. like the Stereo 35 and the SCA 35 from Dynaco. Those are all 17.5 watts per channel. You'll find that number. Once these people kind of settle on these numbers, they go, yeah, it's 17.5. That's what it's going to be. Well, mine's going to be 40. Let's go to the next slide. Oh, and this is some notes that, do they people get these? Well, this will be on the,
Yeah,
Yeah.
all of these
Yes.
are gonna be cleaned up, put
Yes.
up, and so
Kent promises me these are all going to get cleaned up, put on somebody's site.
Linear Systems is.
Linear Systems.
Is gonna put them up, and they're all gonna be on, the Burning Am site or linked.
Right.
So, I know the video quality isn't great here, but you'll have all of
Yeah.
this stuff clear.
These are nice PDFs in their form. You Kent? I also take some questions.
Oh,
No.
and
But
just
go ahead.
before we move on, what is the bias point that you choose in your art?
As far as just a negative bias on the grid, it's about 17. It'll be in between about 15 and 17, depending, of course, on the tube. You know, tubes range. The reason we match tubes is because there is a large range between the bias voltage and the output current. And there's a discussion going on right now. How many of you are on Audio Karma? Is that popular at all? Is Audio Circle? How many is Audio Circle? No?
Yeah.
I've been banned, so don't go there. I got banned by the guy from Synergistic Research. He's a bully.
That's a good thing to be banned by.
Yeah. Dennis, David, whatever he is. What? Ted Denny. It's a name to know. He'll sell you a used car. So there's this big discussion on karma that I entered into because people are talking about bias the wrong way. They say, I have 27 millivolts of bias. I said, no, you don't. If you walked up to a ham radio guy or you walked up to Kent and you said 27 millivolts of bias, he'd say your tube's burning up. You probably have 27 volts of bias or 30 volts. So here's what's happened for all of you. I'll make it really quick. You're measuring the voltage drop across a small resistor, like a 1 ohm resistor. Since it's 1 ohm, you can convert each millivolt into 1 milliamp. So the proper thing to say is my tubes are idling at 30 milliamps or 20 milliamps or 40 milliamps, and I don't know what my bias is. I'm adjusting my bias to get that, and I can put a voltmeter on my bias, but the voltmeter on my bias is not going to tell me where to set it. The current through the tube is going to tell you where to set it. So I started this thing on Audio Karma just to have some fun. And it's been a lot of fun. It's been going on for like a week. And people want to argue with me, and they just won't let go. And it's like, I'm saying, look, I just want to get this straight because you guys are all using the word bias improperly. And I'm telling you, I'll even tell you how it happened. It happened because the transistor people did it to us. And then, because they turned idle current into bias. And I said, I don't want the tube people turning idle current into bias. So you adjust the bias to adjust your idle current.
I only have dumb
Herb.
questions, but my dumb question for today is, how do you know when you have the bias right? Basically, go back. How do you know which bias you want?
Well, in some cases, you might even find kind of a little null at low frequency, at low levels. But generally, it's pretty much a straight up thing. As you increase the idle current, which means to decrease the bias, that's where people got really confused. You're decreasing the negative voltage to make the current higher. Then you're going to see this trade-off with current and distortion. And if you go for that really low distortion, which some people do, like Audio Research, they don't have to use as much feedback, but then they suffer bad damping, and people, and everyone who thinks feedback is bad, just get over it. It's just not bad if it's done right. The Futterman amplifier that's highly revered, there's a version of that has 100% feedback. He even put a feedback control in the early versions. And one of the positions is unity gain 100% feedback. And then you kind of dial it back from that if you want a little gain. Futterman was a very, very smart guy, and it's too bad that his work didn't get more recognized. But he came up with something totally original, and I'm going to make them again someday. I've made a couple, but they're really cool. So, Herb, to answer your question, sort of adjust it where you like it. And maybe, if you like a little more distortion, you kind of turn it down. You just get more third harmonic. And if it's a single-ended amp, you get more second.
The reason I asked is, so far you've been referring to load lines,
Yeah.
but not so much. You never mentioned transconductance in this.
Oh, yeah, transconductance is a really bad thing.
It seems like that might happen.
I meant to say that with triodes, by the way. When we look at preamp triodes and most everyone's matching transconductance, that is absolutely the wrong thing to do. Because we don't have transconductance amplifiers. We have amplifiers that depend on mu. It's the mu of two tubes you want to match if you want the gains. Let's say your preamp has tubes that are shared left and right. You want the left and right gains to be the same because you don't have the balance control anymore. Well, you want the two sections of each tube to be matched to each other. You know, this whole thing about matching, by the way, if you call up somebody who sells tubes and they say they're matched, of course they're going to say they're matched, and they're probably not matched. And then if you say, what are they matched for, you might get an answer like transconductance. Well, what did you do it on? And then if you said to them, well, you know, really we want the mu matched. And they go, oh, yeah, that's matched too. Okay, it's all matched. Sometimes people ask me, I say, well, you mean you want the same color? You want the same size, you know? It's like a pair of shoes, pair of boots, what do you want, you know? You want a matching outfit, you know, what do you want? So let's see if there's another page after. This kind of runs on to one more. I want to make sure I didn't miss this one. Now, people are paying a lot of money for this. You know what this is? This is a glorified 6BQ5 EL84. And all they did was they added one more screen connection. They made it so it's pretty universal as long as you don't use one of these particular pins. You've got to watch out for that extra screen pin. I forget where it is. And then the only other thing they did is they put an extra little cooler. If you ever look at the top of a tube and the wires come up, there's a little U-shaped piece of black metal sometimes. That's a cooler. And sometimes you'll find a cooler on the, you know, the first grid is the first pair of posts, and the second grid is the second pair of posts, and this is really easy, and the third grid is the third pair of posts. Well, for some reason, the different people put coolers on different things. Like an EL34 has the coolers on the suppressor grid, those two plates that kind of come out on a Siemens, or most people copy each other for the coolers. So this has a grid 2 cooler, a little bigger, and the other thing that they claim, and I don't know how much I want to believe it, that they can bring extra grid power out the extra lead and cool the grid through the socket, through conduction. And I go like, you know, that little wire inside, that's really kind of small. I'm not sure I believe that, but what the hell. But so anyway, this tube, if you compare the two, where you get the screen dissipation, which is in here somewhere, you'll see it in the better version. The screen dissipation of this tube is a little bit higher. I mean, maybe quite a bit higher. I think it might be another watt or two higher. And I don't know why people are lusting after these tubes, but you know, that's audiophile tube rolling for you. So David Manley and I think we started that, but I'm not sure. But I got buttons that say Nimble Tube Rolling Society. I should bring some sometime. Do y'all know about the thing David Manley and I got into in Stereophile years ago? Those letters? I guess I should publish them. They're really funny. He's gone now, so you can't get me. Any more questions before I sign off? I don't want to take in someone else's time. Yeah?
Yeah, another one, dumb question, I'm afraid, but,
That's okay. They're on.
you mentioned that cathode bias doesn't work except for musical instrument amplifiers. So what do? So you're just talking about the cap?
Well, yeah, cathode bias is tough when you put it on the bench and you look at what happens with cathode bias is the crossover distortion in the middle comes in sooner than it would if you had fixed bias. Because what happens is the cathode resistor charges up and it tends to cut the tube off. And there's a couple ways around it. You can try to clamp it. Supposedly, Bobby Carver has some trick he's doing with a 6AL5, and if anybody knows if that trick is going, I'd like to look at it. I'm not sure it's good, but you know, Bob, he likes funny things. And 6AL5s are around for cheap. But in a guitar amp, you know, I worked with Seymour Duncan on guitar amps and stuff, and it's kind of what the player wants to hear. You know, when you overload a guitar amp, then there's a sound you may want, and that sound may come from cathode bias, or it may come from, you know, God knows what else. But I will tell you something interesting that Fender did, and I always wondered about this. Fender has a control on the back that influences the hum. And what it really is, it's not a traditional hum control. What it is that the power supply is so poorly filtered that they want to balance the current in the two tubes to cancel the hum of the power supply. And because they only have like, you know, 20 microfarads here, and they didn't have big capacitors to put in there, so they go, well, it's going to hum, but we can kind of balance, because usually a hum control has to do with the filaments. This is a hum control that balances the current. You have a question, yeah?
Yes, thank you. Do you think regulating the bias voltage is a good idea?
It only is a good idea if you regulate the G2 also. And we're talking about pentode amplifiers, right? We have to be specific.
Stereo 70.
If see in a stereo 70, you're ultralinear. So now you got a problem.
Oh.
Because you can't do the screen separately. And very few people, it was interesting that, I guess Audio Research, they did regulate screens in a lot of their amplifiers, but those are all pentoed. But there is a trick, and I guess it's time for me to tell people before I die. I don't know. I'm not going to die anytime soon, but I felt like it's, don't ever hurt myself moving those boxes. We're gonna start having some open houses at Music Reference, and y'all come. We'll advertise it someplace. You know. We just moved recently, and we're cleaning up the place, and want to get the electrostats hooked up, and I make these nice electrostats and 5,000 volt amplifiers and crazy stuff like that. That's the way to drive an electrostat. You make a 5,000 volt amplifier, and there's no transformer, and you're directly to the electrodes, and it's heaven. Let me tell you, you can.
Audio amateur had schematics for that.
Yeah, I wouldn't build that one. You got to watch what you build out of some of those magazines, man. They're bad. Mine's real simple. Mine's kind of based on what Beverage and Acoustat did, but I have an all-tube front end, and it's really simple, so it's nice. But your question was, wait a second. We're back to come back to the regulation. So the trick I'm going to tell you, you should listen to this. The trick you should do, and another designer friend of mine just found this. The guy who does CAT, Kent Stevens just came up with this, and so he said I shouldn't tell anybody. He said we should keep this a secret. So now I did this in the RM9. What you do is you deregulate the grid supply. All right. So what you're really trying to do is make the grid supply go negative faster than it would if you didn't do the trick. And the trick is a Zener diode in series with a bias supply. And you get the right value Zener. And what happens is the Zener holds this voltage constant. Herb's lighting up on this one. He's going to do it. You got to give me a nickel. Yeah, well, you put the diode in there, and it provides a constant voltage of a certain amount. So it upsets normally the bias is going to just go up with the power line, and the G2 is going to go with the power line. And the trick, by the way, is if you look at some of these curves, if you know the mu of the tube, and by the way, you can find the mu of a pentode by looking at the screen grid. It's determined by the screen grid. In other words, the change in grid voltage for a change in screen voltage is the mu of a pentode. People don't talk about it much, but if you turn the pentode into a triode, that's what you get. And by the way, all of these tubes, the 6550s, KT88s, they're all about 8. All right? So that means that to keep the current constant, you've got to have the grid bias, when I say grid bias, I mean the negative, going up 8 times faster than the screen grid. And that'll stay the same. So you get a Zener diode in there and a certain... See, other people do it backwards. They put the Zener diode in there to regulate and keep the G1 constant, but the G2 is going up at a factor of 8. And that's why a lot of amplifiers, you put them on a variac, you turn them up 10%, and then the current goes up 20%, the voltage goes up 10%, the dissipation goes up 30%, and you're already in trouble. I mean, that's why you take things like Conrad's and Audio Research. Well, Audio Research at least regulated the screen. So that was a good. See, if you regulate the screen and the control grid, then you're fine, because the plate doesn't matter. You know, once you see a flat plate curve, if you want to back up to one, like 6550, once you see a flat plate curve, you got to say, hey, the plate voltage does not influence the plate current. That's what it means when it's flat like that. I noticed that the KT150s actually have quite a bit of slope. And by the way, if anyone's read the KT150 datasheet, it's all wrong. And it's on a Tunsil datasheet, so it looks like a Tunsil datasheet, but Tunsil never made a KT150 or 120. Mike Matthews made those. And Mike's, I hate to say he's not dead yet, but his technician doesn't know how to measure a tube. And I called them up, and they didn't seem to care. So I'm going to publish some curves for his tube someday. Mike's gotten just, he's old and cranky and whatever. We only go to 6550. Keep going, it's way back there. It's a GE one, when you get the GE thing. And it's the one, there you go. Then the next one after that, there you go. Okay, look how flat that is. From 100 volts to, what's that, probably 400? You're only going up a fraction of a division. And they're really flat down here too. This is going on down here, but they're really flat out here. So it means that your plate voltage can change a whole bunch and your plate current's not going to change. So what I did on the RM9s, actually on all my amplifiers, is I overdo the Zener thing. Because what I want to do, if you do the Zener thing just right, it depends on what you want, you could have the plate current always stay the same. If you overdo it, what happens when the plate voltage rises, I want the plate current to fall a little bit, keep the dissipation constant, just in case somebody has a really high line. I'm the guy that'll take one of my amplifiers and I'll put it on the variac. You know that switch that goes from 120 to 140? Let's flip it up to 140. I give these amps 140 volts for several minutes. And I feel really good about shipping an amplifier after I've given it 140 volts. You realize, by the way, your homes are all now 125. So if you're dealing with, and higher, I've seen. So put your digital voltmeter on your power line sometime and watch it. It used to be high at night when there's less load. I'm not sure why they're cranking it up so much, but they are. So if you have 117 volt amplifiers, you want to take a look at what you might do to help them out. Like a Stereo 70 is running right up there at kind of at the limit. The other problem, by the way, at the high voltage is the filter caps in Stereo 70s are pretty much at the limit too. I could tell you a story about that. But yeah, Kent.
I have done it in a couple of my repairs for customers and just put a CL90 thermistor in there.
Yeah.
The primary AC side. It doesn't lower it very much.
Yeah.
A couple of volts, but it also gives you a soft turn on.
Gives you a soft turn on.
Which
That's
is nice
nice.
on.
If I were doing it, I would.
Tube amps.
I do funny things at my house. And someone noticed it the other day. Said, "Is that a Variac on the floor over there next to your amplifier?" I said, "Yeah." When I'm not playing it loud, just turn it down, man. Why burn up the tubes? Besides, when you make a 5,000 volt amplifier, now and then a tube flashes, and you kind of go, "Oh well, we don't need that. Let's just turn it down." But if you really want to listen to it loud, then you turn it up. But with a Stereo 70, what I would do is do like a bucking transformer. Buck off 10 volts or something.
Yes.
And if you don't know what a bucking transformer is, just look it up.
Whoops, what?
Yeah. What's that?
It was leading, wind.
Oh. Well, I don't want to eat into someone else's time. Am I like, I know I'm over, but what time is it? Oh, only 2 minutes. We started late. Was that including the starting late? No. Okay. This is like Congress. I want my 5 minutes. Stop the clock. Any more questions? No? Well, then if I've run out of questions, I think I've run out of things to say. I hope I have. But I mainly wanted to show you my off application for the RM10 because it's contentious. People, they don't believe it. And the place I was at showing it, the guy who was arguing with me, who's doing simulations on a computer, he just said it can't be done. And I said, well, but the amplifier's right here. I brought it. We just listened to it. Are you telling me that I'm lying about the specs? It does what it says it does, and they've been out there for, I don't know, 15 years now. There's hundreds of them out there, and they work just fine. So, there they go. Well, thank you. Lovely being here. Thanks.